Now let's give a definition of our Sturm-Liouville problem. Okay, the definition of Sturm-Liouville problem. And you can use this definition to check whether the problem set you are trying to solve is fall into the Sturm-Liouville problem set or not. Okay, so a Sturm-Liouville equation as definition is a second order ODE of the following form. Okay, you have negative d over dx px y prime plus qx y equals to lambda omega x y. Okay, where your px is bigger than 0, your qx is bigger or equals to 0, and your omega x is bigger than 0. And those px and qx are the coefficients for y double prime and y prime. Sorry, it's for the px, the coefficient for y double prime, and the qx is for y. And you also equals to lambda omega times y, where this lambda, this omega is called the weighting function. And because this Sturm-Liouville equations is second order ODE with boundary value problem, so we usually interest in the solution side, the solution which is yx, okay, by x on a bounded interval a, b. So your x is in the range of a, b, under some homogeneous boundary conditions. Okay, so the Sturm-Liouville equations needs to satisfy this form, where the coefficient has to be bigger or equals to 0. You have a weighting function as well. And usually you need to be interested in a boundary conditions where the boundary set is fall into the integral of x between a and b. And what do I mean by homogeneous boundary conditions? We can write alpha 1 ya, which is your initial point when x equals to a, plus alpha 2 y a prime equals to 0, beta 1 y b, which is your final point, x equals to b, plus beta 2 y b prime equals to 0, where alpha 1, alpha 2, at least one of them now equals to 0, beta 1, beta 2, at least one of them is now equals to 0, so that you will have the conditions passing 2 points of, and that is the boundary value problem, right? And you have this homogeneous boundary conditions where in your ZBC matrices, think about before when we talk about ZBC matrices, the W1 and the W2 will be equals to 0 for this case. So this is a homogeneous boundary condition where this part is equals to 0. And you will have at least one of the alpha 1, alpha 2 is now equals to 0. One of the beta 1, beta 2 is now equals to 0. Then together, this BVP is called Sturm-Liouville problem. So it has the two parts. One part is the form of your ODE. Second part is your boundary conditions has to be homogeneous. Then this boundary value problem is called Sturm-Liouville problem. Okay.